Hello everyone, and welcome to Amity University, Mumbai. Myself, Dr. Renita Jobir, Associate Professor from Amity Institute of Biotechnology, and the in charge for the Amity Center of Excellence in Astrobiology. And along with me, we have our Honorable Vice Chancellor, Sir, Amity University, Mumbai, and Dr. Penna Suprasanna, Sir, the Director of AIB. Dr. Siddharth Pandey, the head for Amity Center of Excellence in Astrobiology, and my colleague, Dr. Pavitra Shekhar, Assistant Professor, Amity Center of Excellence in Astrobiology. So a hearty welcome to all the participants as well as Dr. John, who is the speaker for today. As you all are aware that we have launched our MSc in Astrobiology and Space Sciences program, which would be starting in August 2023. And while going through the various rounds of interactions with the students, so we had a lot of queries coming in. So that's when we felt that there is a need for addressing many of these queries one by one. So we have thought of a session of webinars from the pioneers who are in this particular field. So today we kickstart our first session. And before we begin, I would like to call upon Dr. Penna Suprasanna, Sir, to give his welcome remarks.
Yeah. Good morning, everyone, and good afternoon to Dr. John, our Honorable Vice Chancellor, Professor Santosh Kumar, Sir. Welcome you, Sir. And this day, as Dr. Renita said, we are going to have career guidance and opportunities being, the talk given by Dr. John Clarke, President of Mars Society of Australia, and it's a good opportunity for all, for everyone to listen to him and then learn about it. Yeah. Honorable Vice Chancellor, we are very thankful to you, sir, for all the guidance and support for taking the course ahead, because it has been for over a year, and he was the guiding force. He said we have to start this course, and we are very happy that it has started. I welcome you all, and thank you, Dr. Renita. Please go
on. I would like to invite Santosh Kumar, Sir, for his address.
You want me to give a figure?
Sir, maybe you can welcome John.
Yeah, thank you so much. I welcome Dr. John, Dr. Siddharth, all the faculty of Astro. I don't want to be a stumbling block in between the very fascinating talk, which I am also going to hear. So thank you for giving this opportunity. Please go ahead.
Thank you.
Okay. So now we would welcome John. Dr. Jonathan Clarke is an adjunct professor in astrobiology at Amity University, Mumbai, and he has spent over 40 years working in Earth and planetary science field as a researcher, lecturer, minerals and energy explorationist, and environmental geoscientist. He's currently a system scientist for Human Aerospace Private Limited. Jonathan has got a lifelong interest in space exploration and has been the president of Mars Society of Australia since 2012. He currently lives in Canberra, Australia, with his wife and cat. So, John, welcome once again.
Thank you very much, Renita. It's good to see you all. Many of you are friends, and the rest of you are just friends I have not yet met. So thank you again for inviting me to do this talk. And when I was invited to do this talk, I was given this topic about talking about career paths in astrobiology. And although I've studied ordinary biology as well as astrobiology, I really am at heart an astrogeologist. So hence the change in the title. And I thought I'd call it Pathways because astrobiology, astrogeology are very new fields, and like the Mars rovers, as we progress both as disciplines and as individuals into astrobiology, we are carving new paths across formerly untraversed terrain. And I thought the best way to do this, to share what it's like to have a career in astrobiology, what the opportunities are, what the opportunities aren't, the best way I can do it is simply to share my story. Bearing in mind, it is just my story. It's not someone else's. And so if you want to become an astrobiologist, it's a bit like how the Earth has become a habitable planet. To understand that, we delve into the past. So this is going to be fairly autobiographical, but I hope it's of value to budding astrobiologists and astrogeologists. So this is a beach near where I grew up. My family and I would go to this beach almost every Monday afternoon. It was our family tradition. And growing up on this tropical island in South Thailand, places like this played a part in putting me on the road to becoming who I am now. I would go snorkeling here. As an 8-year-old, I learned how to snorkel, and I would wonder scientific questions like, why in the rocks in the foreground, why is there a small coral reef around that and not at the other end of the beach where that building is now? I would go and very bravely dive down to 3 or 4 meters, and there was seagrass beds there, and I didn't know what seagrass was. There was just these little plants growing all over the seabed. And I brought some home in a jar and had a little aquarium on my table in my bedroom. And I thought, seaweeds aren't supposed to have structures. But, this is like a leaf. It's got a central stem and veins in it. And it was only years later that I learned that seagrass is a flowering plant. And I also got very interested in the geology of the island, which was at that time a major tin mining center. So there is tin in the granite there, and it is washed out and was found in the river valleys, and also in drowned river valleys beneath the coastal waters. So my interest in geology and biology and how they interact really goes back to my childhood in this wonderful place. When I was in my late teens, I moved to Tasmania off southern Australia, the big island there off southern Australia, to finish my education. And this mountain wasn't that far away from where I finished off my last couple of years of high school. And that was where I first learned learn about studying geology in a systematic fashion. For the geologists in the background, in the audience, that mountain there is made up of Ordovician conglomerate, and the rich fertile soils in the foreground are basalt plains. But it was also a very pivotal year in my career, because up to that point, despite all the diving I had done and the snorkeling and canoeing around the coastline, I really wanted to become an astronomer. I had a little telescope and looked at the moon and the planets, and astronomy was what really brought my interest up. But it was when I was at college that I had to face the sad realization that I did not have the mathematical ability to be an astronomer. And this was quite a painful discovery. It meant I had to repeat a year at college to change subjects. And in fact, it was quite a few years before I would ever bring myself even to look through a telescope at the moon and planets and nebulae and so on. But I was in the library one day and I picked up a book that talked about geology of the Earth in the context of the Earth as a planet in the solar system, as a potential planetary system, one planetary system amongst many in the universe. I thought, well, if I can't study the planets out there, I can at least study the planet I'm living on. And that is what set me on the course to seriously study geology and become a geologist. So I did my undergraduate studies at the University of Tasmania in Hobart. studied geology in places not very, I did my honors year, my 4th year, at a place not very far away from the mountain there on the left, at a place called the Tiger Range, not Indian tigers, but Tasmanian tigers, which are native marsupial carnivores, sadly extinct. And this is some of the views I got when I was working in the field in my 4th year. We used to do 2 theses at the University of Tasmania in our 4th year. We did a field thesis, which was on the Tiger Range, but we also had to do a reading thesis, a big literature review. And I wanted to do it on the geology of Mars. And my supervisor said, no, there's no point doing on geology of Mars. NASA has got that all tied up. They've got some of the world's best geologists doing that. There's nothing that you would learn from doing that. Instead, I did my honors project, my reading project on the extinction of dinosaurs, particularly focusing on the idea that a large asteroid struck the Earth 66 or 65 million years ago, causing catastrophic environmental damage that wiped out not just the dinosaurs, but many other species and higher groups as well. This was very controversial at the time. It's interesting when you're a 4th year student and some of the professors basically get up and say, what you're saying is rubbish. This doesn't make any sense at all. But I persisted, and I'm very pleased to discover that, of course, with the passage of time, this idea has not only been strengthened, but is now largely accepted as correct. After that, it was time to go out into the real world. So I got a job in Central Australia looking for industrial minerals, particularly salts, and also for oil and coal. So this is just a picture I grabbed off the internet, but I spent weeks sitting on drill rigs like that one in the background, surrounded by red sand and scrub out in the desert. I then, after about a year of that, I got laid off. Mining geology, exploration geology is a very cyclical employment situation. There was a downturn, I got laid off, and I went and did a PhD at a university in South Australia. And this is the area, or a view from the area I was working in at Wilkawilla Gorge in the Flinders Ranges of South Australia. And I spent many months camping out in this environment, usually by myself, and doing field work. I've climbed all those hills there, both up along the valleys and along the ridge tops. I knew it like the back of my hand. And then after that, I then went and worked for another mining company, this time in Western Australia, and a place called Kambalda, which is a nickel and gold mining town. And I was supervising about 5 kilometers of drilling a year. So after 5 years doing that, I figured I was somewhere down near the bottom of the Earth's crust. So I had two of these rigs to look after, and I spent most of my time logging the core, collecting the samples, taking them back, analyzing them, mapping the results, and so on. Now, the thing about all of these projects, although they were not directly related to planetary science, let alone astrobiology, I still had an interest. And so, I walk across some of these red sand dunes, and I'd sort of think in my mind, well, maybe, walking on Mars would be a little bit like this. Working on drilling, I hadn't really kept up to date with a lot of space exploration technologies, but I was aware that people were looking forward even then to the importance of using drilling technology on the moon, on the Mars, to get subsurface information. So I was sort of aware that what I was doing had applications to Mars and the moon and other planetary sciences. Also, the rocks we're drilling there are some of the oldest rocks on Earth. They're over 2.7 billion years old. They were formed, the nickel is found in what we call komatiites, which are very magnesium-rich lavas, which don't form today. They're only found in rocks dating from the Archean, with very few exceptions. Archean being more than 2.5 billion years ago. They formed at very high temperatures. These were lavas erupting across the surface at 1500 degrees, forming lava rivers and lava deltas, and the nickel sulfides were settling out at the bottom, in the bottom of the channels, rather like alluvial gold or alluvial tin settles out. Very strange deposits. And so, yeah, in addition to working in a red, dirty, dusty environment, I was also starting to think about the history of planetary evolution and how that might affect the different kinds of rocks that we would find. The same company then moved me, after 5 years there, moved me to Melbourne and put me in charge of a laboratory, a research laboratory. And this had a worldwide brief, mostly in Australia, but also in particular in the Philippines and South America. And it was an amazing experience. We got to fly out to White Island in New Zealand and study the hot springs there. That's actually an active volcanic crater. We had to wear gas masks when we got out of the helicopter. We were looking for copper gold deposits in the Philippines, with a prospect on the sides of that volcano on the top right there called Mount Maitutum, down in the southern Philippines. We found a very large copper gold deposit in Queensland called Ernest Henry, which is still going. And it's just been announced that's got another 20 odd years of mine life. So that was quite an interesting experience. And of course, I had the privilege of visiting the Atacama Desert in Chile, which is the oldest desert on Earth. It goes back to the late Triassic, early Jurassic, places, that area there, which is near the Chuquicamata mine, gets only about 5 millimeters or less of precipitation each year. Very dry, very cold. You can see all the snow and glaciers and the mountain ranges, the Andes there in the background, and quite high up. Preparation, if you like, for working in Ladakh. But all good things come to an end. There's another recession. I was looking for work again. I eventually ended up at the Australian National University here in Canberra. That's what brought me here. And that was an interesting time, a difficult time in many respects, but I did get to work with students on little islands in New Caledonia like this. We'd take students out to these reefs and they'd snorkel around them, they'd take samples, they'd measure transects and learn how, geobiology, about how algae and sediment forming animals like corals and so on work together to form carbonate factories, building these reefs, which are limestones in the making. But after that finished up, I ended up at Geoscience Australia, which is our national agency, and I spent over a decade with them, mostly working in environmental geology, looking at groundwater, again, back to drilling, sometimes in difficult to access places. There's poor old drill rig there, bogged to the axles, trying to get across a mud flat along the coast. A lot of geophysics, such as ground penetrating radar, and interesting encounters with crocodiles. But during that time, in fact, just before I finished at the Australian National University, I had an experience which, like discovering I couldn't do astronomy, transformed my professional career. I was surfing the internet, as you do, at work, and I came across an organization called Mars Society Australia, and they were looking for someone who could lead an expedition. This was in 2001, who could lead an expedition through Central Australia to looking for places to set up a Mars analog research station. I thought this looks interesting. I did a little bit of research on the society. I didn't want to think that I was going to be traveling around the Central Australia with some strange cult, and they seemed legitimate. And I spoke to some of the people there and ended up co-leading the expedition. And we spent 3 weeks traveling through Central Australia, looking at Mars analog sites like radioactive hot springs, sand dunes, deeply acid weathered terrains, And we ended up picking a site near where all those four-wheel drives are in the bottom right, at a place called Arkaroola in South Australia. Like I said, this was transformative because for all the years subsequent to that, at ANU, at Geoscience Australia, I realized that I could, in addition to the paid job, I could, as an interest, carry on Mars research with a volunteer organization. And pretty much all the research I've done since then that's related to Mars has been through Mars Society Australia. And so we've done all sorts of things. I mean, these are some highlights. They're actual analog simulations where you wear simulated spacesuits and you work with simulated habitats. So two different ones, one in Utah, one in the Canadian Arctic. The longest of these have been 3 months. And also been a lot of not involving full simulations where everything you do is you try and do as you would on a Mars mission, but other expeditions where you go and study particular features of interest, such as the giant mudcrats there. That's with Professor Vic Gostin from Adelaide Uni, or testing particular drilling technologies, either standalone or whilst wearing a spacesuit, evaluating how people perform in different types of spacesuits, how they can do field biology or field science, testing robotic rovers. And these we've done all over the road, all over the world. You know, we've done them in Utah, in the Canadian Arctic, in all over Australia, New Zealand, and of course, more recently in Ladakh through the work that Amity University has supported there. Now, through all those experiences, right, all of those projects, all those studies in different parts of the world, I was able to absorb a lot of information about how we go about choosing sites to explore, to understand a planet, ours, for example, and therefore by extension Mars, how we would go about looking for particular signs of life, early life on Earth, perhaps sites that might host early life on Mars. And if we start thinking about taking this expertise from Earth and applying it to exploring the other planets, especially again Mars, which is the most accessible planet to us, to understand its early history, to understand its development, its evolution over time, to see whether or not it's habitable, and in fact, whether or not it's even inhabited, even if only by sort of green slime, like this picture here of an astronaut picking up a rock and discovering, you know, she's found life on Mars. If we're going to do all of that, because Mars is a very hostile environment, we need to be dressed for the occasion. And that means, if you like, spacesuits for Mars, or perhaps better, extravehicular activity suits that are specific to Mars. And this sort of brings me into the work I've been doing. Unlike the other stuff, it hasn't been volunteer. I was actually paid to do this with Human Aerospace, a Melbourne-based company which had a grant from the Australian government, amongst other things, to develop concepts for new types of spacesuit, EVA suits, to use on Mars. And the driver behind it is that the current spacesuits, EVA suits, just aren't good enough. I mean, this is called the XEMU. This was NASA's latest suit, developed up to last year. They spent almost $500 million on, and it's rubbish. Sorry, NASA. It's 6 times too heavy for astronauts on the surface of Mars. It's more than twice as stiff. You know, when that's inflated, pressurized gas, it's about as stiff as a basketball. And can you imagine living inside a human-shaped basketball trying to work on the surface of Mars? key systems like cooling that it uses won't work on Mars. So this sort of technology just will not do on Mars. It's not even saying it's going to be hard to use on Mars. It just won't work. It will put people in a suit like this and put them on the surface of Mars. They will die. We need new technology. We need a new approach. And this is what we came up with. This is not unique to human aerospace. People have been working on this idea for 70 years. There's been some successful research on components, but in terms of actually building a full suit, is still at a very early stage. What it's called is mechanical counterpressure. What does that mean? Well, we've all seen elite sports athletes wearing those sort of skin suits that help improve their performance. We may have seen pictures or even known people who have been in hospital for burns, and they wear these elastic support stockings over parts of their body or even the whole body to help them heal. Well, they're compression suits. And what mechanical counterpressure spacesuits do is they take technology, increase the pressure so it's sufficient to sustain human life. You fit the astronaut with a pressurized helmet so they can breathe, and you wear a comfort layer under that. You wear the appropriate plumbing and so on in case you need to go to the toilet while you're wearing the suit. Space travel is not always romantic. And of course, a protective layer over the top. And a suit like this will weigh a lot less than a conventional suit, less than 20 kilos. You'll use about a third the energy you do walking around in it as you would if you wore a conventional spacesuit. So you need less oxygen. You would sweat less, so you'd need less water. You generate less heat from your body, so that the suit is much easier to cool. On top of that, it's much more flexible. The closest thing to wearing one of these that some people here might have done is a very thin wetsuit. And I've worn gloves made of this material, and it's completely different to the thick, stiff, blown up, inflated gloves that you get with a conventional suit. So we recommended this technology very strongly, and we're now looking for potential investors to take it to the next step. Would be actually building a suit, a full body suit that we can test in a high altitude chamber. So how did I end up there? Well, I ended up there with a paid job developing tools for astrobiologists, for astrogeologists to use on Mars in all the experience I had previously. The fact that I used to go scuba diving for fun and sometimes to do field science, or the hiking I did in places like the Flinders Ranges and in Tasmania. Taught me all about how to, what is a suitable load for a person to carry working in rough terrain, or the experience working in remote areas in Central Australia and elsewhere, fed back into the safety requirements, the issues with what you need when you're working in a vehicle, out of a field camp. Even the volunteer firefighting is relevant because you are carrying heavy load in a hostile environment. You need to be able to respond quickly to evolving situations. And of course, the bottom left there, all the analog research, simulation research, wearing mock-up spacesuits in Central Australia, in Utah, and on Devon Island. So this brings me, and I'll close in a minute and hand over to questions. This brings me to the takeaway lessons that I've learned over my career that I would like to share with people who are at the start of their career. First is an uncomfortable truth. There are more people interested in astrobiology and astrogeology than there are paid jobs. So if you want to have a career in it, there's a lot of competition out there. Secondly, very few of the astrogeologists and astrobiologists I know, not all of them, but there are very few, started out in astrobiology or astrogeology. They started out being biologists, geologists, astronomers, engineers even, of all things. So if you want to be an astrobiologist or an astrogeologist, the best thing you can do is build your expertise through being the best biologist, the best geologist, the best astronomer, the best engineer you can. So that when the opportunities come, you've actually got a wealth of experience, a foundation you can draw on. And do that, maintaining the interest, indeed, maintaining the love you have for the idea of understanding other planets, understanding the possibility of life on other planets, how you might look for them, how to go about it. Build a network, because you never know how that will pay off. Not that we form friends in case it pays off in a few years' time, but get to know people, make friends with them, because you don't know what opportunities will come out of friendship. So going back to, where was it? Yeah, this slide here. This fellow, that's me there, a bit younger and a bit skinnier, out in Central Australia in 2001. This guy next to me is Dr. James Wiley. He ended up being my boss in the Human Aerospace Project. Yeah, more than 20 years later. The contacts we made on that trip resulted in me getting paid work as a systems scientist, designing suits that would enable people to do things like this. Every day is a school day. The thing that, through my career, I think I was always picking up stuff. I thought, well, how would this work on Mars? How would this relate to what I learned about lunar craters? How would we go about looking for things like stromatolites on the surface of Mars, as I was, say, visiting Shark Bay or looking at some of the earlier stromatolites? Every day is a school day. So there are things you'll pick up working as a medical researcher, working as an ecologist or astronomer or a civil engineer or a aeronautical engineer, that can all come together at some stage and help build your expertise relevant to becoming an astrobiologist or astrogeologist. Another lesson is be prepared to work in the discipline part-time or even as a volunteer. I mean, when I met up with the Mars Society in 2001, Australia did not have a space program. In fact, there were people saying, and I'm not exaggerating here, that people were saying if Australia would get a space agency over their dead body. They're very hostile to the idea. Even when we got a space program, there's still a considerable degree of a reluctance for a number of years towards doing astrobiology, planetary science, and so on. So if you want to get into this field, look for organizations where you'll perhaps be able to do it part-time or as a volunteer until that opportunity comes along to do it full-time. Seize the opportunities. A mentor of mine who passed away a few years ago she told me life is not a rehearsal. So if there's an opportunity that comes your way to follow your dream, grab it, do it. And last of all, have fun in the process. So over to questions.
Okay, thank you, John, very much. That was quite inspiring, your life journey, how you started off as a geologist and went on to make spacesuits.
Indeed. And
Okay.
look, just to follow up one more thing about the idea, you never know how it's paid off. I mean, I met Siddharth online, and he wanted to meet up, and we had friends in common. Another friend that I met through the Mars Society, and look where he is now. So, through meeting Siddharth, through the Mars Society, I'm talking to you now. Siddharth's disporting himself at JPL, working on hardware that will go to other planets. So, yeah, grab those opportunities.
Yes,
Make
yes.
those friends.
That's true. Because I am a microbiologist and now I've ended up into an astrobiology field. Okay. Participants, in case you have any questions, either you can post or else you can raise your hand if you would like to ask the question directly. Okay. Till the time they ask, John, so there were a few questions that we had come across during our interviews. One was after you do a master's course specifically into astrobiology, are there better PhD opportunities in the field of astrobiology? Or is it like you can get a preference more?
Yes, there are. Certainly, for example, in Australia, we have the Australian Centre for Astrobiology in Sydney. They have PhD courses, or not courses, sorry, PhD opportunities. Many other universities around the world do so. You'll have to be prepared to travel because there are not that many of them. They are there. There's not that many of them. There are more than there were. Also, in addition to actually doing, say, a PhD in astrobiology, you also should look at the possibility of doing a PhD in something that's relevant to astrobiology, but maybe addresses wider issues. So, for example, I had a PhD student here in Canberra a number of years ago. She came from a physics background, and she did modeling of where on Mars would we be able to find liquid water. So it was applied physics. She did a lot of remote sensing, used a lot of remote satellite data from Mars on surface materials, on heat balances and heat and thermal profiles. But of course, if you know where the water is, you can where there is significant traces of liquid water on Mars are the places where you might be able to find life. They're habitable environments. Are they inhabited? We don't know, but at least you've narrowed it down. If you want to look for life on Mars, the narrowing down of the field is really, really important. Mars, the surface area of Mars is the same as the land area on Earth. So to try and look for perhaps the handful of sites where life could exist is worse than a needle in a haystack. So we say, well, look, we've got to narrow it down and liquid to key spots, and liquid water is a very good space to do it. Where there's perhaps methane coming out of the ground is another one. And this is a technique you actually learn in mineral exploration, because you want to find a gold mine in Australia. I mean, Australia is a big place, so you start looking for the right sort of host rocks, the areas that have the right sort of geophysical and chemical anomalies, and then sooner or later, hopefully, you will find a gold mine. I found a ton of gold for the company I was working with. I couldn't keep any of it, but I found it. And so, yeah, this is what I mean about things that you learn in wider careers are useful if you want to do astrobiology or astrogeology, particularly in honing in on particular features. Yeah, hope that makes sense. But as I said, be prepared to travel. I mean, there are a lot of people from India who are now working in the US doing space-related sciences as students in Europe, in UK. There was a lady called Anushri Srivastava, who was on one of our analog simulations in Ladakh, and then joined us in Utah for a 3-month simulation there, and then went to the Arctic the following year for 2 months. She's just finished a PhD at the Open University in London, or in the UK, working with people in the US as well. So, yeah, grab those opportunities. But remember, if the opportunities don't come up, you can still look for opportunities for doing it as an interest. Join a society. Make friends with people who are doing that. I mean, your friend at the university who is researching astrobiology may well want someone to go into the field with them, to hold their rocks or drive their car, you know, collect the samples, wade out into the hot springs. And there's ways of doing it there, all of which means you're part of the game, part of the story, part of the adventure.
John, since you spoke about society, if you can let our participants know, like, how does Mars Society Australia support student research or student projects?
Yeah. Now, we don't have a lot of money. But what we do have is we have people who can mentor students. So I've supervised a number of masters and 4th year and PhD students through being in the Mars Society Australia, because often people say, well, I want to work on Mars, and they find a university supervisor who will supervise them, but that supervisor may not know much about Mars at all. We can supply that extra help, that extra advice. And most PhD students have at least 2 supervisors anyway. And universities are generally quite happy to support that. We can provide logistic support. So this isn't in astrobiology, but we have supported university students doing PhDs in psychosocial studies of small teams. You know, when we send an astronauts to Mars, there'll be a team of anywhere between 4 and 10 people, unlikely to be more. How do they get on? How do they interact? How do people from different backgrounds, how do you get on? How do you select them? How do you resolve conflict? And so psychologists and sociologists love guinea pigs. And we can, by running these expeditions to Utah and Central Australia, we can provide a whole cage full of guinea pigs for them to work with. And so we've done that, or we've been, you know, in some of our expeditions, other people have been doing that. And we worked with people from Australian universities, from Germany, from Russia, from the US. And yeah, not astrobiology, but still space related. What else can we do? We can network. You know, someone comes to someone in Australia would say, look, I'd like to, you know, work in hot springs in Ladakh. And so, okay, well, there's people at Pune, at BSIP. Yeah, there's Dr. Siddharth Pandey. There's a whole bunch of people that I can recommend that they get in contact with. So that's another area in which a volunteer society can enable research to be done and become part of that that journey.
Thank you, John. There's a question. There are a few questions. I'll take them. Does what you take, it's from Meher. Does what you take in an undergraduate degree matter if you want to get more into field work?
If you want to get into field work, it's good to choose an undergraduate degree that has a lot of field work, and look at perhaps the university where their biology or their geology has a strong field component. Now, being somewhat older than perhaps quite a few students, I've noticed that in recent generations of students seem to be far less interested in doing field work. And a lot of universities seem to be cutting out their field programs, which I think is a great pity. Being old school, I think the best geologist is the person who's seen the most rocks. So I think it's really good to get that experience early. But if for whatever reason you can't, it's not the end of the world. Yeah, you can move into areas that are more theoretical, like my student, Arita, I mentioned earlier, who was a physicist. I mean, she doesn't do field work, right? But yeah, nonetheless, she can still do great work. You know, you can have someone who's a microbiologist whose field area comes in a test tube, right? Or a little Petri dish. That's okay. You know, the microbiology can be really important, and lab-based work there is really important as well. But I mean, if you're interested in geology, if you're interested in finding exotic habitats for life, then yeah, field work's really good. Sooner or later, you're going to have to do it. So you might as well get into it early and enjoy it while you have the chance.
Next question is from Nikhil Bajaj. What are the parameters to find the geographical site for astrobiology exploration?
That's a very good question, and it's got lots of facets. So one of them, we're applying to Mars. I mean, the first strategy that NASA was using was follow the water. Find out about the history of water on Mars, and you'll find out the history of Martian habitability. Find the areas of Mars where liquid water is or was present, and you'll be able to find those locations. But there are other strategies you can use. So, for example, you could follow the energy. I mean, what are the energy sources that early life, microbial life, the sort of life we'd find on Mars, are likely to be concentrated around? And one of those is hot springs. So how do we find? So if you want to study early life on Earth and use that as an analog to Mars, we go to the Archean rocks, more than 2.5 billion years old, and look for fossil hot springs, like in the Pilbara in Western Australia. If you want to study hot springs that help find what they might look like on Mars, you go and study terrestrial modern hot springs like those in Ladakh or in New Zealand or Italy or Iceland or whatever. If you want to look for hot springs on Mars, you do that. In the minerals industry, because hot springs are often associated with mineral deposits, there's a whole range of geophysical and geochemical and other techniques, remote sensing techniques, to find out where the hot spring activity is. Not modern hot springs, but ancient hot springs. And we can apply those to Mars with all the magnificent data sets that people at JPL and the European Space Agency and Roscosmos and the Chinese Space Agency, Japanese Space Agency as well. All these agencies have collected data which is publicly available, and you can start sifting through that, just like a terrestrial explorationist would, to find where the hydrothermal activity has been. So there's many ways, depending what you're after. Are you after the energy? Are you after the habitability because of liquid water? Are you after potential food sources? So you look for things like deposits rich in sulfur or rich in iron or other chemical compounds that microbial life can utilize as a resource to enable it to thrive. So there's multiple strategies out there. They're all useful. They've all got their place, and they all help us understand better.
Hi, John. So there's a question from Reshmi, who is pursuing a PhD in microbiology and wants to have a career in astrobiology. So she wants to know if there are any opportunities in India or abroad for the same.
I can't comment specifically about India, perhaps the other people in on this discussion can do that. But I do know at Pune there are a number of institutions there who are working in microbiology and biochemistry. Dr. Sudha, for example, is one at Pune. Very, very able, capable microbiologist and biochemist. Tremendous reputation overseas. There's almost every aspect of microbiology. Yeah, could be, particularly if it's a geomicrobiology, is Mars relevant. So, for example, in addition to whether or not there's life on Mars, things like how do you clean your instruments to such an extent that you're not going to get false positives when you send them to Mars. So there's the planetary protection side of microbiology. And that is relevant to all sorts of other terrestrial applications like sterilization of equipment for medical procedures. So this is what I mean. There's all sorts of things we can do here that can be applied to Mars further down the track. So if you're a microbiologist, maybe get some skills in development of sterile instrumentation for biomedical research and build a career in that. And then when the opportunity comes, India is sending a Mars lander and they want experts in sterilization, maybe you'll be the one who says, pick me. And the same thing with samples coming back. So both the European Space Agency and NASA and also the Chinese space agency are looking at bringing samples back from Mars. How do we study them to make sure they're not carrying some sort of bacteria or virus that's going to turn us all into flesh-eating zombies or something? I mean, there's plenty of silly movies out there that get people very worried about this possibility. And so people are going to take this threat seriously, at least until we show that, no, then they don't have these bugs on them. So, yeah, can we do that in our current? Can we handle the samples in our current level 4 containment, the sort of places where they study Ebola and diseases like that? Or do we need a special facility? So there's also, and that comes into the engineering side. How do we engineer a system to enable us to do that?
So the next question is from Gurpreet, which is an interesting question. He asks about which degree courses should he go for, which would help in building a strong foundation in astrobiology? If there are any specific courses or,
Yeah. Look, I think it's such a diverse field that there's no one course. I mean, astrobiology courses do exist, and it's good to do them. But remember, they're mostly to introduce people to the field. What you want the skills is to have the skills that which will enable you to move the field forward. So if geology is your thing, do geology. If chemistry is your thing, do chemistry. If instrumentation is your thing, spectroscopy. What are the spectral characteristics that help us recognize microbial life? Do that. I mean, look at Dr. Siddharth Pandey there. He's an engineer, and yet he's also works in astrobiology. So wherever your strengths lie, play to your strengths and look at how that can be applied for that. Because all of these different disciplines feed together to help us do astrobiology, both looking at the early Earth and looking for life elsewhere and building the technology to do so.
I can chime in there a little bit, John, to let you get a little bit of rest for your voice. So, Gurpreet, the question that you've asked is an important question, and a lot of students have posed that question, that is there any prerequisites for pursuing a career in astrobiology? And we can all share our personal examples here. Renita, Pavitra, John, and myself, we come from different backgrounds, but we are working in some way or the other in astrobiology. And And it all depends on the student and their own personal interests. If they are more experimental oriented, are they more interested in life sciences? Are they more interested in engineering? So you can find your way into astrobiology in several ways. What we are trying to do with our master's program is to be an enabler or a facilitator for students from various backgrounds. So it is a hard task for us to build a program that can cater to students from various disciplines. So that has been a challenge for us. But we are aiming to have students coming in from different backgrounds, whether that be geology, biotechnology, or engineering, and provide to them some of the fundamental subjects, some introductory topics that they will start with. And then based on their interests and which direction they would like to go, they can proceed to do an internship and then later on a dissertation, master dissertation, with a mentor of their choice that the university would approve. And that would allow them to specialize and get some training in an aspect of astrobiology that is relevant to their liking and their interest and their background. So we could have a student with a geology background who has done a BSc geology, who might do an MSc in astrobiology, and they might focus on the geology aspect of the topic that they are interested in, where they apply what they have learned from an earth science perspective to a planetary science perspective. And the same can be said about a student with a biology background who is interested to apply their skills or sharpen their skills that they have learned in their bachelor's in the master's program. So it's a very open question that you have asked, but it's a good question because a lot of students have asked this question. And it's important to highlight this very aspect, that it is a broad field. And the more you study, the more you read into it, you will get a better understanding of how you will eventually fit into astrobiology. So, yeah, Renita.
Yeah, so Siddharth, pertaining to this, there is a question from Prachi, who is in a second year of ME Environmental Engineering. She says, I want to work on a topic that is in line with astrobiology. Can you guide me for a problem statement? Siddharth, if you can.
Probably not astrobiology as astrobiology, but the challenge of humans living on Mars requires a lot of good environmental engineering solutions. And so someone who's actually worked in environmental engineering in fields has a lot to offer. I mean, we take, for example, we take for granted we can breathe. But of course, on Mars, the oxygen you breathe has to come from the Martian environment, where it's mostly as carbon dioxide. So how do we extract that oxygen? How do we dispose of the carbon dioxide we respire? Do we recycle it? Do we dump it back into the environment? Water. Now, we can recycle water, and people do. On the International Space Station, the Chinese space station, they recycle the water to a very high level, better than 90% efficiency. I think the Chinese have recently demonstrated 95% efficiency. But the remaining 5%, how do you dispose of that? Because it's tied up in human waste. And we produce, between us, half a kilo or so of human waste every day, dry weight. How do you dispose of that safely on Mars? Do we incinerate it? Do we turn it into compost and use it to feed the garden? Yeah, and remember, this is a closed system. So if it goes wrong, people will die. So this requires clever environmental engineering, good detail in human health and so on. So right across the board, the challenge of human people living on the surface of Mars, it requires good environmental engineering and will enable great astrobiology, because we can be blinded by the efficiency of robots. All due respect to robots, Siddharth, that JPL makes, they are horribly slow technologies to explore Mars. I mean, the time lag alone is a big issue. I mean, so the Mars rovers, at the start of the day, they upload the commands to the rover. It does what you hope it does. At the end of the day, it tells you whether or not it's done it. And if it hasn't done it because of some default setting, you got to start all over again. So the average rate of progression of a Mars rover is a few meters a day. How successful would you be in exploring a site on Mars if all you could do is cover the distance from one side of a lounge room to the other? They only carry tiny numbers of instruments. I think the record is about 6 or 7. How well can we explore or answer scientific questions with only a handful of instruments? And of course, they're all built in with particular assumptions and design limits. I mean, they're fantastic technology. I'm glad we've got them. But if we really want to explore Mars from an astrobiological perspective, a proper geological perspective, we need boots on the ground. People who can think as they go, who don't worry about time lag. And that requires all of these other environmental engineering sides of things as well. There's room for everyone on Mars. Everyone in astrobiology, some way or other.
And thanks, John, for that answer. And just to add on, Prachi has asked this question that you have just answered. And Prachi, I would recommend to reach out to us over email, and we would be more than happy to provide you more guidance on that in case if you're interested in doing a master thesis in astrobiology, with relevance, because what you've asked is something that can actually be tested at some of the analog sites that we've been working in, from a contamination control point of view and several of the other aspects that John pointed out. So it's a good area of work that is quite relevant, and your background in environmental engineering is very much needed for enabling astrobiology research. So can we ask, can we try to answer this question from Meher? She asks, do you think astrobiology will gain a lot more attention in the coming years and hence reveal more job opportunities than it has in the past decade? John, any thoughts on that?
I think yes. I think yes. I mean, you think when I was a fourth-year student, the only people sending probes to the planets were the US and the Soviet Union. Now we have not only the US and the Soviet Union or Russia, we have Japan, the European Space Agency, China, India, the UAE. And I think we'll be seeing more and more countries developing the technologies. The costs will come down. They have come down. The technology becomes more available and more sophisticated. We'll see more and more space agencies, more and more countries sending probes to the planets, to the moon, not just Mars, but Venus, Jupiter as well, to the asteroids, returning samples. And we have the possibility of people actually going to Mars. And I think it's much closer now than it was when I was an undergraduate student. And they'll be international, just like the International Space Station has people from many countries on it, either citizens of many countries or people from expatriates, if you like, from different countries going there. People from the US and Canada and several European countries, Russia, Japan, Saudi Arabia a few weeks ago. I think the opportunities are just going to grow. And that's wonderful. So it'll be a long time before there are 1 million people employed in astrobiology, but we're getting there. And remember, for every person who does perhaps a direct astrobiology task, there'll be lab technicians and engineers and other people supporting them. So, yeah, I think it's a great field to get into. And the more we
That-
find, the
yeah.
more people get interested in. I mean, again, when I was an undergraduate university, a student at university, Mars was the only place that we thought was of astrobiological interest. And that was pretty thin. Mars looking much more interesting now. On top of that, we've got, there are people who think there may be signs of life in the atmosphere of Venus. We think there's interest in some of the asteroids for a whole range of purposes. There's people interested in the ice worlds, Enceladus around Saturn, Titan around Saturn, the big moon, 4 big moons of Jupiter. Even Pluto potentially has astrobiological interest. So it's not just, it's all about Mars. It's now all about almost the entire solar system. Mercury is probably not a candidate, but almost everywhere else is.
Thanks, John, for that. I think I agree with you. There's a lot of missions that will be happening in the next decade, and they will be employing a lot of scientists and engineers. And for those of you who are currently going to be pursuing your PhDs, masters, you will be in the next few years eligible to apply for those positions. So I thought I'll just take one question, merge a couple of questions from Gurpreet, where he asks about career opportunity at NASA for astrobiologists from India and how can they go for that. So a little bit about my experience. So I think there are several opportunities at a few NASA centers for astrobiologists, mainly the Jet Propulsion Laboratory, where currently I am located. There's the NASA Goddard Space Flight Center on the East Coast. There's NASA Ames Research Center. So there are some NASA centers which have research programs where they constantly hire people as full-time scientists, engineers, postdocs, and there are also summer internship opportunities and other visiting student researcher opportunities for which people from most nationalities are eligible to apply for. And the application process is pretty much the same. They are listed on the careers page. So if you look at the NASA Astrobiology website, there is a careers page where all of these opportunities are constantly listed. So those of you who are interested should subscribe to those websites so that you get updated whenever such a listing is out, and you can apply for those positions. And what I have seen, at least in the last few years, especially after COVID started, the situation overall around the world has started improving and people can travel more easily now. There's been a lot of people coming to NASA from most countries, including India. In fact, in the last few months, I've seen several Indian students who have come to NASA JPL. So a lot of opportunities are there, and NASA is very, I would say, conscious of the fact that there is a lot of interest and enthusiasm in India, in Indian students for working there. So they constantly keep looking at finding ways to give opportunities to people there, and not just at NASA. I mean, there are opportunities at most space agencies that are available. But of course, they're limited to research opportunities. But currently in astrobiology, I think that is what one is interested in. One very interesting question that I find here from Rishabh. Maybe John, you would like to answer that with all of your experience. He has asked, how does one know that the field of research is one's calling in life? Like, how is it that you're pursuing something that you feel that, this is something that I was supposed to do and I'm doing it?
When you wake up at 2 o'clock in the morning and start thinking about it.
Well, that's not always a good thing. Sometimes.
Yeah. Look, some people sort of wander into it and it sort of happens.
Yeah.
But look, I read when I was about 10 years old, I read a book about people going to Mars, and that seized my imagination. And so decades before I joined the Mars Society Australia and I started to my amazement, working with people from the US, from Europe, from Russia, from India, I was imagining what it would be like to work on Mars, you know, and like I think I mentioned that. The dream was there, the passion was there. I mean, I grew up in the Apollo program. I saw, read about, I didn't see because we didn't have a TV, but I listened on the radio to people walking on the moon. And for some reason, that always resonated with me. And all of us have passions like that. It's got to be really your passion and something that you sustain. And look, if it turns out you can't get a career in astrobiology, it doesn't matter. You can still stay interested. You can still follow. Now, it's just like you don't have to be an Olympic athlete to do sport or to follow sport. You can still do that. You can still be interested. You can still talk to the public. I mean, there are plenty of people out there who don't even have a university education who are tremendous communicators, say, of astronomy, because they invest in astrophotography and telescopes, and they're just really good at talking, and they talk to schools, and people go out into remote areas to look at the night sky. You can do that about Mars. I noticed there's someone there asking about artists. Nilesh, a fantastic question. Annalie, who's one of our also Amity people, is an artist. You don't have to even be a scientist. And a lot of people in the arts side of society are actually somewhat skeptical of what we are trying to do. So we need people in the arts, all of the arts, visual arts, graphic arts, literature, music, dance, film, to be able to explain to them why we think that's important, how we can explore for life in the universe responsibly. We need philosophers and spiritual people. So whatever your passion is, you can use it to work in this space.
Nilesh actually was participant in our Earth Space program last year. I believe he's the same Nilesh, and he's also applied for the master's program. So Nilesh, do reach out if you need any help with the application process. I think the interviewing is going on, so all the best with your application for that.
Yeah. And one thing that artists, but just talk about one more thing about artists. I mean, certainly when I was younger, there are a number of big space artists like who were also researchers, and they imagine what these places would look like, what the surface of Titan would look like, what the surface of Mars would look like. And they inspired people like me, inspired our imagination, Robert McCall. So yeah, by sharing a vision or sharing imagination, art, I think, has a wonderful thing to contribute.
Great. Renita, how are we doing on time?
We can take maybe one or two questions more. There's one question from Shriya Neelam, who is asking, can people doing BSc in computer application go for masters in astrobiology?
Yeah, I think that's a question you would be best able to answer, because it's an eligibility question which we have set, right?
Yes. So basically, in our eligibility, we do not have any constraints related to computer application also, because that is also something which we can apply when we look in the field for remote sensing and all those aspects.
Yeah.
That is something which we can actually apply.
Yeah, so we haven't put any constraints. All BSc and BTech programs are open, right?
Yes. BSc, BTech, physical, chemical, biological sciences, all are open. And our course is designed in such a manner that it pertains to all the fundamentals of many of these aspects. And how you can apply your BSc knowledge, that probably we can get you linked to some of our, through our networks.
Yeah, so one thing to clarify, I think one thing which is important to clarify here is that even though most of these undergraduate programs are eligible to apply for this MSc, it doesn't necessarily mean that we will be teaching those subjects. It basically means that you might have that background, and now if you want to specialize in astrobiology, you will have to learn some of these fundamental topics that are outside the scope of your undergraduate program. So you might be having a BSc in computer applications, but you might have to study microbiology and geology. It's not like if you have a BSc in computer applications and you come to an MSc in astrobiology, that you will then be taught computer applications again. So it's important to clarify that. And I think we have also posted now the program structure on the website. So people can look at that and decide whether this is something that they'd like to pursue, because it is important to point out that students who are interested in this MSc astrobiology program, they will have to most certainly step out of their comfort zone. So we will have students from biology who will have to study a bit of geology, and students who have a bit of geology background have to study a bit of biology. But that is what it is. That is what it takes to learn all the aspects. And we are only trying to teach some of the basic and fundamental aspects of astrobiology so that people can understand how interdisciplinary this field is. And it constantly requires you to work with people from other disciplines. And that is what we are preparing you for, rather than you isolating and just specializing in one area and then later on learning in your work environment that you have to actually work with people from other disciplines. So that is what we are training you for as well.
Okay. There is one last question I think we can take. Is ISRO doing something on astrobiology?
So maybe I can answer that question. ISRO currently does not have an astrobiology program. There have been several biological experiments that have been conducted. There was an astrobiology balloon experiment that was conducted a few years ago that was spearled by Dr. Jayant Narlikar, supported by ISRO, where they were trying to collect microbial samples from stratosphere about 40 kilometers above our sea level. But that's actually something that our center has been part of, trying to advocate for an astrobiology program within ISRO. There is a lot of promise because ISRO is now going to be flying humans into space. There is a human space program that is being built, and there will be experiments that will be conducted. And some of the experiments that have been selected are biological experiments that will be conducted in space. In addition to that, our own center has been part of developing two payloads, biological payloads that will be flown into low Earth orbit on ISRO rockets. So it will start like this, where there will be small experiments that can be conducted in space, with ISRO's support. And then eventually, once we have a strong enough, I would say, team of people in India that can be, supported by ISRO to conduct astrobiology. And when ISRO itself is doing more elaborate missions to Mars and, similar places where astrobiology is possible, that will then enable, but it will definitely happen. It's a matter of time. If you look at the space policy that was recently announced by ISRO in, I believe, a few months ago, I think in March of this year, they have already listed extraterrestrial habitability studies as one of the priority areas for ISRO. So it's the first time something like that has been listed. And if you look at ISRO funding program, which is RESPOND, RESPOND is a funding program that ISRO runs where anyone can apply for funding to do research. There are astrobiology relevant areas that are listed there. So at this point of time, these are the avenues which ISRO is supporting. And we are hopeful that in the next few years, there is just like NASA has an astrobiology program, ISRO will also have an astrobiology program.
Okay, I think so. That's a few of the questions I have typed the answers. And I think it's 11:30, so we can go ahead with ending the session. Before we move ahead, I would call Dr. Pavitra for the vote of thanks.
Yes, thank you, Dr. Renita. Well, first, I would like to extend my heartfelt gratitude to our esteemed guest, Dr. John Clarke from Mars Society Australia, for his timely and insightful talk on possible career opportunities in astrobiology. Astrogeology, especially with the new astrobiology course that will probably be beginning this semester. I'm sure it was very useful for students with different backgrounds. Sincere thanks to the respective dignitaries who attended this event and also made it possible. I would definitely like to thank the faculties, Dr. Siddharth and Dr. Renita, especially being faculties of the center, and the students, participants, and even the IT and tech support, to everyone else who helped in organizing this talk. We look forward to interacting more with you, John, in the future, and hoping to see you at Amity University, Mumbai sometime soon. Thank you.
I hope so. I'm looking forward to it very much.
Yes, thank you.
All right.
Okay.
Bye-bye.
Thanks,
Bye-bye.
John.
Right.
All
Thank
right.
you.
Maksud, we can end the session.